transformations with quadratic functions. Okay? Now that we have the basics down about transformations with specifically quadratic functions, let's go a little bit further. Let's talk about some specific, but also some general things about quadratics. Okay? We definitely need to get to some vocabulary today, and we will. But first of all, fill in this table for me. What's going to go in that table? If I take x, like for instance 1, and subtract 3, I get negative 2, right? And I square negative 2 and I get 4, and I say 4 times 2, 8 plus 4, 12. It is too much work. What should we do instead? Yeah, we could use our calculator, couldn't we? So on my calculator, and I'm even going to do it a different way that I'm not sure if I've shown you yet. I'm going to go to a graph, and I'm going to put in 2x minus 3, and square that, and then add 4. I don't care so much about the graph, but I do care about the table, right? So when x is 2, y is 6, right? Because it's evaluating it so it can graph that point, right? So when x is 3, y is 4. When x is 4, y is 6. When x is 5, y is 12. And when x is 6, y is 22. Okay? Now, it's saying let's simplify this function by squaring, distributing, and collecting like terms. Well, what does it mean for something to be squared? X minus 3 times x minus 3. Some of you on the test forgot that yesterday. All you did was square the first term and square the second term. That scares me, just being honest. So this is x squared minus 3x plus 9. When I combine my like terms, x squared minus 6x plus 9, and then I multiply everything by 2, and I get 2x squared minus 12x plus 18, and then I still have this pesky 4 out here. 2x squared minus 12x plus 22. Any questions? You guys with me?
No.
Okay.
Where'd you get the 9?
3 times 3?
Oh.
Sorry, I didn't think I needed to go slow there because that's just distributive property. We've done that a lot recently.
Yeah. My brain is scrambled.
Would this expression generate the same table of values? Would this expression generate the same table of values of this?
Yeah.
Well, the easiest thing to do is prove it, right? So I'm going to go back here to, that's not what I want to do. I'm going to do Control T and get rid of the table for a second. Stop. Stop. Control T, get rid of my table for just a second. I'm going to tab and put this other equation in here. 2x squared minus 12x plus 22. Now I need my table back, so Control T to get my table back. Look at the two y values, f of 1 and f of 2. What do you notice about the values? They're exactly the same. Okay? Did you expect them to be the same? Well, if they're equivalent equations, shouldn't they be the same? Yeah, okay? So these equations are both types, both examples of what kind of functions? Quadratic, good. So I need you to know standard form and vertex form. We're going to use both forms to help us in different situations. One's easier in some places, one easier in other places, and I want you to know both of them. First form you know because we've actually talked about it already when we talked about factoring. ax squared plus bx plus c. Do you remember that? Vertex form, y equals a times x minus h squared plus k. Now, personally, I think it's funny that they make us fill it in right here when it's right here. But whatever, they didn't ask me. Okay? This is all stuff that we just figured out. Okay? When there's a multiplier in front, that a, that is a vertical stretch. If a is greater than 1, if a is between 0 and 1, and so on. We figured that all out. Okay? But it's right there in case you need some help looking back at it. The vertex of the parabola are these specific coordinates. And this is important, so put a box around it or put a star by it or draw a flower. Okay? With the sun. So the flower will grow. See, I would not be good in jail because I can't draw teardrops. So here's some sample problems. Okay, sample problems from quadratic parent function. We have 6 things to do on every problem. 1, 2, 3, 4, 5. Yes, 6. First of all, state if there's a reflection over the x-axis. How are we going to know if there's a reflection over the x-axis? So look on this page at these 4 problems. Which one of these 4 problems, if any, is A going to say yes? Number 2. Because that's the only one with a negative in the front, right? So is it okay if I go ahead and put no? Yes. Okay. Now, some of you, I promise I get this. Some of you are very linear, and you need to do number 1, and then you need to do number 2, and you need to do number 3, and then you need to do number 4. I'm totally okay with that. Okay. I'm trying to give you a different view of this because we've already kind of talked about it a little bit. Okay. Identify any vertical shift. What's going to tell us if there's a vertical shift? If we're adding anything, right? Do any of these problems have vertical shifts? 1, 2, and 3. Where does 1 shift? Up 4. Where does 2 shift? Down 5. Where does 3 shift? Down 4. And where does 4 shift? No. I mean, that sounds kind of disrespectful because it says identify any vertical shift, and you're like, no. But you guys are that way anyway, so it's fine. Okay, what about C? Identify any horizontal shift. How do you tell if there's a horizontal shift? Added or subtracted inside the parentheses. Very good. So where's this going to go? Right 2. Very good. Where is number 2 going to go? Right 4. What about 3? Left 3. And 4? Left 5. Okay, here's a good pre-AP point. Okay, this is a good pre-AP point. Let me tell you this real fast. Jason asked me a second ago, or maybe it was Caden, I don't remember. They look alike to me a lot. So if you go right here, and you said, how do you know that it's opposite, right? You said, how do I know that it's opposite? Well, if I say, let me get a different color. If I would say what's inside the parentheses is x plus 5, what does the formula say? X minus h, right? Well, for this to look like the formula, doesn't it have to be like that? X minus, because that's the formula, x minus, which means h is what? Negative 5. That's another way to think about it, that's the reason that this goes left. Because this value, the value of h, is actually negative 5. Does that help a little bit? Okay, back to our sample problems. What about D? Identify any vertical stretch or compression. And by what factor? No. How do we know if there's a vertical stretch or compression? Do any of these on this page have a vertical stretch or compression?
Yes. 3 does.
3 and 4.
3 and 4. So D on number 1 is no. D on number 2 is no. What about D on number 3? Yes?
Stretch.
By factor of 2. Actually, we shouldn't put yes. I should really put whether it's a stretch or compression, right? Which one is that, a stretch or compression? It's a stretch.
Yes.
Good. Thanks for letting me change my mind in the middle. So what about D? Excuse me, on number 4.
Compression.
Compression?
By factor of 1/2.
Oh, one half? Yeah, it says 1/2, so we should write 1/2, right?
Of course.
Okay, E, determine the standard form of the quadratic equation.
Oh,
How do you do that?
gee.
How did we do it here?
Square, distribute.
We multiplied it all out, right? I'm going to let you do that. I'll do one of these. Which one do you want me to do?
The hard one.
Which one do you think is hard? Number 4, okay? So if we're going to do number 4, I would say, first of all, I'd say x plus 5 squared, so x plus 5 times x plus 5. Distribute, distribute, so x squared plus 5x. Distribute, plus 5x plus 25, which gives me x squared plus 10x plus 25. And then what I have left is to multiply it by a half. What's a half times x squared? Half x squared. Oops, y equals. What's a half times 10x? Plus 5x. What's a half times 25? 13.5? 12.5? Sorry, 12.5. What's left to do besides the other 3 E's? Graph it. Okay? But this is not a problem as far as graphing goes because all parabolas are parent function shape until you start messing with them. Okay? Left 5. Well, I'd have to take this whole thing and move it 5 left, and then I have to squash it by a half. Okay? So normally, let's do number 1 real quick. All I'm doing is moving an up 4 and right 2. Up 4 and right 2. So every point moves up 4, right 2. Does this change shape at all? Is there any multipliers on it? So it's still the same shape. So if I go over 1, I should go up 1 because 1 squared is 1. If I go over 2, I should go up 4 because 2 squared is 4. So from the vertex, if I go over 3, I should go up 9. Good, because 3 squared is 9. But it's like up here somewhere, right? And I know that parabolas are symmetric about its vertex, so that is what my parabola should look like. Now 4 is clearly different though, because there is a compression by a factor of a half. So first of all, I move left 5, because I'm supposed to, right? But this time I go over 1 and I'm supposed to go up 1, but I only go up half of that. This time if I go over 2, I'm supposed to go up 4, but I'm only going to go half of that. So I'm only going to go up 2. I'm supposed to go over 3 and up 9, but I'm only going to go up 4 and a half because that's half of it. Does that make sense? So that is what my parabola should look like on that one.
After you figure it out, you just not put it in the calculator.
You can, except I want specific points on these. I didn't want specific points on the other one. I want specific points on these. So you can, yeah, you can go to the table, but here's the deal. How hard was that I just did?
Oh, I didn't understand it.
But how hard was it? It wasn't hard at all. It's going to take a whole lot more time to plug it in the calculator, go to the table, and start plotting points from the table. Okay? I'll do another one so you can see it, but I need to do one of these first before I do another one of these. Fair enough? because you have some of these on your homework. Okay? Over here, we figured out all the transformations, figured out the equation was given to us, we figured out all the transformations, and then we graphed it, correct? Over here on 5 and 6, it graphs it and wants the equation. So we're going backwards, aren't we? Okay? Let me tell you about this, guys. When we're writing the equation, vertex form is way easier to use. Okay? Y equals a times x minus h squared plus k. Did I put a squared on the front? Yeah, I did. Okay. This is the form I want to use. Okay? Where's my vertex? 1, 2, 3. 1, 2, 3, 4, 5. My vertex is at 3, 5. Didn't I just fill in 2 of the values? Y equals x minus 3 squared plus 5. So remember, it's HK is the vertex. Remember that? Now all I have left to do is figure out if this is parent function shape. And Jason, I think this will help. At least I hope it will, with what you were just struggling with. Okay? And I know you weren't the only one. I have to figure out if this is parent function shape. How do I do that? For in the vertex, if I go over 1, down 1, that should be on the line. If I go over 2, how far should I go down? 4. 1, 2, 3, 4. If I go over 3, how far should I go down? 5, 6, 7, 8, 9. Is this parent function shape? Yes. So is there a number for A? No, but what is there for A?
1.
A negative, because it's upside down, right? Okay, a negative. But guys, here's the deal. That's the answer. We're done. Okay? Hopefully, if that didn't help, and I think it did maybe a little, yes? Then hopefully number 6 will help for sure. Start with the vertex form. Okay? Find the vertex. 1, 2, 3, 4, 5. 1, 2, 3, 4. So the vertex is at negative 5, 4. That's HK, right? So y equals x plus 5 squared plus minus 4, right? Oh, that's a negative 4. Pretend that's a minus. Now I have to figure out A. Is A positive or negative? It's positive because it's opening up, right? Is this parent function shape? Over 1, up 1. Over 2, up 1, 2, 3, 4. It's not, is it? How far did it go up from here? How far was it supposed to go up? 4, and it only went up 2, so that is half. So that means this multiplier should be half. We can check and make sure. If I go over 3, how much was I supposed to go up? 9, because 3 squared is 9. How far did it go up? 2, 3, 4.5. Right there. Okay. Any questions about that? Does that help a little bit with what I was talking about a minute ago? Yes? Okay, good. So you're responsible for practice problems 1 through 6. Practice problems 1 through 6 is what you're responsible for tonight. Okay? Any questions? Any questions?
You said, what, the 6?